Thanks everyone for joining. This is a quick overview of some of the research opportunities in KLA India. I'll talk a little bit about KLA also because it's a slightly under the radar kind of company, but it's actually influencing your lives. Every life of every individual on the planet has been touched by a company. You don't know it yet, but you'll know why that is once you go through what I have told you today. Right. So before I get started, a little bit about me. I thought it'll be interesting to hear my journey. So I got my BTech in IIT Madras in 2005 in computer science, and I actually was at UIUC from 2006 to 2011 when I did my PhD. It's actually the coffee shop where I actually wrote most of my thesis, faking that I was sitting and working there, but that's where I was. So after I finished in 2011, I actually came back to India. I came back despite a fair amount of opposition from both my advisor and my parents. But I thought that this is where the fun was at. And I've had a wonderful journey over the last more than 10 years now. I first worked in R&D lab in Intel for about 4 years, designing some of the chips that actually power your CPUs today, power your laptops today. And then for about 6 years, I worked as a principal engineer in a company called Multicore, where I was responsible for a lot of high-performance software that powers pretty much most of the OTTs that run in the world, including Prime Video and Disney+. I also was an adjunct faculty at IIT Madras for a few years, and I joined KLA about a year and a half ago as director of the Advanced Computing Lab. My goal here with the rest of KLA is really to try and make sense of what this whole deep learning and AI are doing in event processing and how they fit with GPUs. That's my journey. I hope that we came here with the hope that we're able to find similar people who are looking for similar journeys with KLA or others. And I hope that we are able to find people like that. And if you have questions about this journey for me, feel free to reach out to me and talk to us. So overall, the industry that we work in is the semiconductor industry, and really the semiconductor industry has been growing by leaps and bounds since the turn of the millennium, and it really is skyrocketing into what looks like will become $1 trillion industry by 2030. The only other $1 trillion industry that's there in the world today is oil. So really, semiconductors are becoming really big, right? I mean, oil is obviously fundamental to all your living, and semiconductors are expected to reach that level, and that really is because there is digitization of literally everything that you touch today, from your cell phones to your car to your refrigerator to your heart rate monitor, your home. Everything is digitized. So that naturally requires some kind of semiconductor to run, and that is what is driving the semiconductor industry's growth overall. But semiconductors are really, really challenging to manufacture. I don't know how many of you have thought about this, but a semiconductor is actually manufactured in a clean room that is about 10 times cleaner, so it's about 1,000 times cleaner than an operating theater. And we all know how clean an operating theater is. So semiconductor really is very, 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 very clean, right? And the reason why it needs to be so clean is because the kind of structures that we're trying to build are very complex, and any subtle defects that are available in this manufacturing can really result in the loss of billions of dollars, because these fabs take billions of dollars to really create. And so any subtle defects, like for example, you see this little line here, you see this little dot, you really have to look closely at the screen. You'll see there's a bridge there because of which this line is a short. And that's a problem. And what KLA really does is that KLA produces tools that are used in the semiconductor manufacturing process to inspect whether the manufacturing process is going on correctly. So we do three things. We do defect inspection, where we really use very advanced tools. I'll show you a picture of a tool for you to get an idea. We use advanced tools to find critical defects. We then also use these tools to do what we call metrology, where you try to measure critical parameters to check whether the manufacture is going the right way. And then finally, we use these tools to do a lot of data analytics and extract critical information that enable the manufacturing factory to actually understand, am I going to get good yield? How long is it going to take me to actually manufacture my chips? And how long am I going to be able to get the return on the investment that I've made, which is typically tens of billions of dollars too. And so a quick demonstration of our tool really in operation. This is really what we call a product wafer. Think of it as a circular 300 millimeter diameter wafer that has each square that you see here is actually a semiconductor chip. And this at some stage in manufacturing, it's going to be months before you can electrically test it. right? So what our tools actually do is you can shove this into our tool, and this is what our tool looks like. It has a very advanced microscope inside and has a lot of compute. And through the microscope, what you can actually do is you get an image, right? And this image is what we call a defect map, where there's some basic processing, initial basic processing done from the microscope, and some basic computing, which actually says that each of the blue dots that's present over here is possibly a defect, meaning that that is not in line with what the design told you that it should be manufactured like. But naturally, you can imagine that this really is a tool and a real wafer. You cannot have so many defects. There's no way the chip is going to work, right? So because of inherent quantum effects in the manufacturing process, there's a lot of noise. And really, our algorithms are responsible to really cut the noise out and to identify what we call the critical defects, some of the examples that I'm showing over here. So our tools really crunch through terabytes of data to very advanced image processing and compute to convert what we see as a defect map from our optics to actually the real defects that are important for us to identify and fix so that the manufacturing goes with them. So just a quick picture to show the various markets we have served. Semiconductor manufacturing or IC manufacturing is one of our primary markets that we serve. In fact, literally every single semiconductor that's manufactured in the world, whether it be the processor that runs a laptop, it be the processor that is responsible for something in your car, in your refrigerator, at some point in its life has seen a KLA tool. And I'm not kidding when I say that I've touched every one of your lives in some way or another. And that's the kind of effect that we have. But it's not just semiconductor manufacturing. We touch several adjacencies, including reticle manufacturing, printed circuit boards, flat panel displays, storage and media heads, all of which have similar problems in terms of inspection and in terms of metrology. So quickly, just looking at our challenges, I'm going to run through this. We generate data at super resolution. Terabytes of data are crunched by our tools to really, like I'd shown you, sift out the noise and find the real defects. And we continuously innovate in the space of image processing and AI. And we try to leverage accelerators like GPUs to really accelerate AI. And so that's really what KLA does at large. As an overview of the company is close to 50 years now in operation. We're headquartered in California. We're present in over 19 countries. We are close to $10 billion in annual revenue. This year, I think we'll get pretty close. We're $8.2 billion last year. COVID has been very helpful for us because, as you know, semiconductors are becoming more and more important. So we grew quite a bit. And we have a very high percentage of masters and PhD because in this industry, really innovation is key, right? We invest double-digit revenue back into R&D, which is very, very rare for a publicly traded company. And so we churn out a lot of papers, a lot of patents across the world to make sure that we can keep the edge that we have in process control. A quick overview of KLA India specifically. We were founded in KLA India close to 17 years ago. We've been leading technological innovation here since 2005. We have over 700 employees that are spread across 3 campuses in Chennai. We're primarily located in Chennai. And we are embracing hybrid working environment also in this post-COVID world. KLA India has really been growing in the value chain. It's been very high in the value chain for KLA Corporation. We have supplied and we have had engineers work across several disciplines, straight from application engineers to software developers. And really now we are at the phase, or we are at an inflection point for KLA India, where we are trying to enable global leadership for KLA from India. And this is one of the reasons why we are here to really recruit top-notch engineers who can come and be a part of this revolution. And we have teams that work across all the way from N-1, that's the previous generation product, to the next generation, that's N+2 generation products. And a quick slide just showing you the research opportunities at KLA. I'll be more than happy to talk about this more. There are more details about both these roles in the website as well, but really there are 2 broad disciplines we're looking for engineers in. One, focusing on artificial intelligence or machine learning, engineers who have the skill, the experience, and the interest to focus on developing algorithms for our tools. And secondly, focusing on HPC, who really are interested to do acceleration or high performance computing and to take these algorithms and to really push the performance edge in terms of the GPUs. I'll leave you with my last slide, just showing you some of our global R&D locations. Really here, of course, we're here primarily talking about India, where we have a software and algorithm R&D center, 2 centers of software and algorithm R&D, and my research lab, the AI and Advanced Computing Lab, are located in the IIT Madras Research Park. But we also have 2 other R&D locations, both in Silicon Valley, California, and in Ann Arbor, where we have a data science R&D center. So we have openings everywhere, and the 2 roles I'm looking for here, you have already heard about. I'll be more than happy to take questions and answer them. And I think I'm on queue. Thank you very much.